Welcome to the last breakfast. Please enjoy the video.
You start by confirming essential prerequisites. Choose a pre-trained model that matches your task and license needs. Install Python 3. 10 or later, create a virtual environment and pip install the model runtime and dependencies. If you have a GPU, make sure drivers and CUDA/cuDNN match the runtime, otherwise plan for CPU inference. Once the environment is ready, collect 10 to 50 representative inputs or a small labeled set so you can validate behavior immediately and iterate quickly. You now load the model using the library API, specifying device equals CUDA if a GPU is available or CPU otherwise. Prepare your inputs, tokenize or resize, normalize pixel values or feature ranges, and batch to 832 for throughput testing. Run inference on a small batch, then examine raw outputs, confidence scores, and timing. Make adjustments to batch size, precision, float 32 versus float 16, or input pipeline to balance accuracy and speed. These choices directly affect latency and resource use. You finish by optionally fine-tuning on your task data. Use a low learning rate, a few epochs, and validation checks to avoid overfitting. Export an optimized model format for deployment, include preprocessing and post-processing code, and add simple health endpoints or sanity tests. If things go wrong, check for common issues. Out-of-memory errors by reducing batch size or using mixed precision, mismatched tensor shapes from data pipelines, and tokenization mismatches. If a problem persists, revert to the working checkpoint and compare inputs.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.